go ahead and get started so we can get a little shut-eye before we're back at it. So I'm going to pray and then we'll get going. Heavenly Father, we just thank you so much for the many blessings that you pour out on us each and every day. We thank you, Lord, for the school and for the work that you do in and through it. We thank you especially, Lord, for the way that you do reveal yourself in your creation, and just pray that you would give us an opportunity to just revel in how you do that specifically through mathematics. We pray that you would bless our time tonight and bless these parents as they endeavor to raise kids to your glory. In Jesus' name we pray. Amen. Okay. So I'm going to give you a little introduction to Singapore math and why we use Math in Focus, and then the second part of the evening we're actually going to have the teachers come up and work a problem from each grade to kind of show you how this program progresses and how what your kids are learning in kindergarten, first grade, second grade are getting them ready for the advanced math that will come. Okay, so we had this evening, I think in about 2014 we held it for the first time to explain what Singapore math is. I think today with so much on the internet and so much talk about Common Core and crazy math and new math and the old new math, and it's really important for our parents to understand that this is something that we've thought through and that we truly believe is the best way for us to teach your students to think well using math. So that's what we want to show you tonight. So I really think one of the most difficult things about our math curriculum is that it says Common Core aligned on the front. Because I think it scares all of us,
and
right?
It's in red.
Yeah, it's like bling, bling. Okay. So I'm going to show you how your kids are learning math and they won't build cars like this. And they're not going to solve math problems like this, okay? But I do always think it's fun to look at these, and I actually looked for this picture over and over again because I don't know if anyone else notices that there's an error on it. Yeah, so that's interesting. But this actually is a really common math problem that they use to show the new math, which really was introduced even before my time, like in the 70s. And so that this is now referred to as the old new math, and they actually have the new math, which we'll get into all of those theories of education and how the United States has a pretty crazy system of how we develop our philosophy of education and change it. So first I just want to talk about what is Common Core and what does it mean that our curriculum says Common Core aligned. So Common Core is especially for math, just a list of goals for each grade level. So they're actually very brief. This is the second grade goals. Any curriculum that meets these goals can be a Common Core approved curriculum, okay? So when you see this, you know, we would say this is not a good Common Core approved curriculum, but it does meet the goals set out. And that's why I think you have to really be thinking and understand the development of the brain to be able, go ahead, to be able to choose curriculums well and really plan a K through 8 education. So the U.S. approach to math results in our country falling farther and farther behind globally. So this is the 2015, which is the most recent OECD, which is the Organization for Economic and Cooperation Development, who kind of tests global countries. We are number 31 out of 36 countries. That's the United States, okay? So you see when you hear like that schools are only creating 40% of their students that are actually proficient in math, that's being compared to people down here. It is very scary when our schools are producing kids, only 40% of them proficient in our math standards, because our math standards are really low compared to these other countries. So what is the U.S. approach to math? It's memory and formula driven. We continue to fall behind globally and then we have a new solution about every 10 years, which really amounts to your kids have been guinea pigs. We were guinea pigs. That was the new math, and then it was the old new math, and then it's the new math. All we've determined is that what we are doing is not working. That's what we have figured out. So I know a lot of us, and I've had 2 of my 4 kids have gone through Singapore math, and I have been there where they're figuring out 3rd grade problems, and I'm, oh my gosh, I don't know how to do this. You know, I have to do it with algebra and then figure out what exactly did I do here, and then I can try and help my child figure it out. And then you realize, wow, you really didn't need algebra to figure out that problem, but because I don't have that really good foundational understanding of our base 10 system. When we are taught math, when I was taught math growing up, it was so based on memory that there was no concrete understanding. And so in the US, what we're doing is really teaching concrete math concepts in an abstract way. So when kids are hitting abstract math in algebra and beyond, they're hitting a wall because they have no concrete foundation to understand the abstract math. And so then they decide, oh, this approach to math didn't work, so now we're going to develop a new one. So one thing, and I say this a little bit in jest, but remember when you want to say to your kids, I wasn't taught math this way, just plug in this algorithm and do it this way. Just remember what that's gotten. We're number 31 out of 36 countries. That's not the goal that we're shooting for. We're not just wanting our kids to be able to plug numbers into an algorithm. We want them to understand what that algorithm is doing and why we would plug those numbers into it, which is very different than what we're doing. So Singapore math is up here. Number 1. They've been number 1 since 1997. So in 1979, the Prime Minister of Singapore came up with a whole new, they're going to overhaul their educational system, and his, what he called it was Thinking School, Learning Nation. So I just wanted to let you guys think about that. Our last 2 educational philosophies in the 80s, it was wait and fail, and the next one was no child left behind. We are not setting a standard for reaching for the stars. It's not about a thinking nation. It's not teaching kids how to think, and it's not trying to help them reach the highest level that each and every one of them can reach. And so that's really more the philosophy behind Singapore. And they actually went from, I think it was 60% of their students were failing to meet English standards, which is kind of funny to me. All these countries are being tested on English, like they have to be English. They have to meet English standards, and we aren't doing it. So they went from 60% were failing to meet it to now they're at 90% of their students are exceeding the standards. And then since 1997, they've been at the top of the list for both math and science. So they have a long track record of educating their students well, particularly, in math and science. So what is the Singapore pedagogy, again, developed in the 1980s to fit this new educational philosophy? It's developing students who are competing globally. So it meets the Common Core grade level goals, and that's why it's called, it's Common Core aligned. That's why it says that, that's all that means. And then it's a very specific pedagogy, and this is what you're going to be seeing tonight. They go from the concrete understanding to modeling to the abstract. So you're going to see manipulatives to the pictorial to numbers and symbols. In the US, this is where we start. This is not helpful for kids. It's a language-based math program that helps children make connections between pictures, words, and numbers, which would be that concrete, pictorial, and abstract. It's an accelerated program that drives all levels. So what this means, in Singapore, I'm not going to go into their whole philosophy, but they wanted to meet the needs of all their learners. So they actually developed different schools and would put kids in different schools based on their learning competencies. And so this program was made so that it could meet the needs of kids who both were excelling and struggling in developing their mathematical skills. And then it's a cumulative program that revisits concepts covered earlier by connecting strands of mathematics. Both of these are very, very classical. They're topic intensive with fewer topics covered per grade level. And then mental math strategies are embedded in the program. So with this, you're going to see tonight how much we build the foundation of the base 10 system. And you're going to see why we are having kids break down numbers and regroup numbers based on the base 10 system. It's a very powerful way to build their number sense. So education is not the learning of facts, it's rather the training of the mind to think. So I really like this, and we're going to take a little detour from Singapore and kind of explain in another context where we use the same kind of philosophy, that we're not just focused on teaching your kids the algorithms, but we're actually going to use the teaching of math to build their critical thinking skills. And we've talked about this, and we do it a lot with SWR. So very few of us learned to spell this way. But I think we've talked a lot about why we do learn to spell this way. And I don't think that any of us do it, or if we were telling you this is how we want your kids to be able to write papers when they're in 7th grade, you would think we were crazy. So we're not doing it so that they'll write papers using this whole marking system in 7th grade. We're doing it because of the way it's building strong spellers, but even more importantly, the way that it is building and preparing their mind for higher level critical thinking skills. So I'm going to say that Singapore math is a lot like SWR in that the whole word language approach is very much like American math models. So I don't know if that makes sense to you or kind of helps you to think. But some of the things they say, that the whole language approach uses students' languages and experiences. Well, every language approach, when kids are reading, is using their language and experiences. So that's kind of a strange, thing to take for why you would do this. You make sense out of what you read. Makes meaning out of what you read and express. So the whole language is, they might not be able to read every word, but they're going to read it, and then they can go back and guess at the words based on the context, right? So we're definitely not going to break things down. So the curriculum is organized around themes and units to increase language and reading skills, which sounds really good, except when you teach kids how to read this way, you're limiting them to only being able to read about things that they already know about, because they have to have a context to guess at the words. So, and then it says it's not the best approach for those with learning problems, but there's ways to adapt the approach. So the nice thing about when we break something down and teach it in a way that's going to build their thinking skills is that it is the best approach for all of our learners. So I kind of want to take this and extrapolate it to Singapore math. So this is actually a real problem that I did with one of my students when I was doing therapy, and I gave him blocks and I said, can you show me with the blocks what 6 times 3 is? Which, we can kind of giggle, but it's actually really sad, because this person only has a very abstract understanding of numbers. Like, there's no concrete understanding of 6 times 3 is 6 groups of 3. And I think this is what modern American math is doing to our students. And it's not just sad because it's very hard to do math when all it is pure memorization, but you're bypassing building so many of the opportunities to build up how these kids think. and you're really limiting how far they're going to go in math. So Singapore math develops thinkers. It builds the number sense through a concrete understanding of our base 10 system. That's something that you're going to see with all of our teachers tonight. We teach our kids to rely heavily on the base 10 system. It teaches students to compose and decompose numbers and to group and regroup numbers. All steps of the problem are important. It teaches students why problems are solved the way they are. So they aren't just learning, this is the formula to solve for the area of a triangle. They're actually learning why that formula will tell you what the area of, did I say triangle, rectangle is. So it preps the students for the rigor of higher math subjects. And I think you'll see that really well tonight when we get into the 5th and 6th grade math problems. You'll see how everything we're doing in the early grammar stage is getting them ready for higher level mathematics. Again, we don't primarily teach math so that students can learn algorithms. That's a byproduct. We're primarily teaching math to develop students' mathematical thinking. Singapore uses a fluid understanding of the base 10 system to create students who can easily manipulate numbers in their minds, creating greater mathematical fluency. So again, when Mr. Atef does his math problem, you'll see that by the way he's solving them. And then Singapore math gives us a unique way to understand the relationships from different perspectives, which develops students' flexibility in thinking. So this is one of the things just in our culture is we're not very good at seeing things from different perspectives. It's just where we are culturally. And I think math is an especially unique subject to be able to teach students how to see things from different perspectives, whether it's showing them that there's a lot of different strategies they can use, that you can think about numbers from a lot of different ways, and that you can solve problems using, multiple people can get to the correct answer using different strategies to solve one problem.
Hi, I'm Mrs. Lee and I'm the kindergarten teacher. So at this stage of kindergarten, we're just using a lot of manipulatives, a lot of concrete materials like this, counters, things like this with our students. Kids are exploring numbers, they're visualizing them in a variety of contexts and relating to them in ways that aren't limited to written or abstract methods. This is really so that they can understand what numbers mean and that they have value. So as Mrs. Bonecutter talked about, for us we're going to start with concrete. So we have a word problem, and the word problem is there are 5 black cows. Oh, this is in your packet, so the first page of your packet. There are 5 black cows and 2 brown cows. How many cows are there altogether? So the first step would be concrete. I would give them a tub of manipulatives, and they would have to use the manipulatives to be able to represent the number of black and brown cows. It's also really important that they have like a 1-to-1, that it's 1 means 1. Okay, so they have to pick out 5 and be able to count 5. So from my tub, I'm going to count 5 black cows. 1, 2, 3, 4, 5, and 2 brown cows. 1, 2. Now, how many cows are there altogether? Well, what I teach them is that they have to pull each cube away so that they can count and not get confused as to what they already counted, which happens quite frequently. So, 1, 2, 3, 4, 5, 6, 7. How many cows are there? 7 cows. Okay. So that is the first step. It would be concrete. You're doing that a variety of ways, many different types of cows, color cows, other animals. Okay, so the second step is pictorial. So this time they would be drawing. So they would have a black marker and a brown marker, and they would draw circles to represent the cows. So they're going to draw 5 black cows. 1, 2, 3, 4, 5. And 2 brown cows. 1, 2. Now, how many cows are there all together? They need to count and slash each cow that they're counting. And this is so, again, they don't get confused as to what they already counted. So they would count 1, 2, 3, 4, 5, 6, 7. There are 7 cows altogether. All right, the last step is the abstract. So, as Mrs. Bonecutter said earlier, these symbols are very abstract to a child. Just the numbers themselves are a symbol. So it's important for them to really understand and appreciate that these symbols carry a value. And it's not just about counting, it's not just about memorizing their facts or numbers, but it's about true understanding and true number sense. And understanding that numbers have value, and that's what kindergarten is really about. And what we're trying to build as a foundation for everything else that they're doing later. So now we have a picture of the cows. So we have 5 black cows and 2 black cows, and now they have to write the corresponding number sentence for this. So we're going to do the same thing. We're going to count and slash out the black cows first, and then we're going to write the number. So 1, 2, 3, 4, 5, and I'm going to write the number. And then I'm going to count the brown cows, 1, 2. And because we are trying to find out how many cows there are all together, we are adding 2 sets of numbers and we're trying to combine them. We're going to use addition, and we're going to put a plus sign and an equal sign to find out how many there are all together. This time I'm going to use my fingers, and our hands are a human number line, so you carry them wherever that you go, and so they can count this way, and you always start at the left hand pinky. So if you look at it, if you look at your fingers, it's really like a display of a number line. So they would count 1, 2, 3, 4, 5, and 2 more, 1, 2 makes 7. It's a mirror image this way. So 7, so I would write 7. And how we would say it is after 5 and 2 is 7, or 5 plus 2 is equal to 7. So those are the 2 ways I can say it. And that is my example.
Good evening. I'm Mrs. Simonji, the first grade teacher. As Gina mentioned, the foundation, especially in first grade, is the base 10 system. We emphasize making a 10 and the importance of learning this with small numbers so they could extrapolate to larger numbers later on. We show this with concrete manipulatives, then with pictures, and then with abstract symbols, including the all-powerful number bot. So here's our problem. Andy has 9 stickers. His sister gives him 5 more. How many stickers does Andy have in all? So in first grade, they are very familiar with the 10 frame. They get this in kindergarten. And so with this problem, we too do a lot of manipulatives. We would count out 9 stickers in our 10 frame. 1, 2, 3, 4, 5, 6, 7, 8, 9, and his sister gives him 5 more. So we would put that in the second number bond, or the second 10 frame. 1, 2, 3, 4, 5. And because we want to make a 10, we would take 1 from the smaller group and we would move it up into the large group, and now we would have 10 plus 4, which is easier for first graders to solve than 9 plus 5. Okay. And commonly we often say, let's make a 10. The kids also practice at home with, if I have 5, how many more do I need to make a 10? We encourage our students to do that in the car with mom and dad. So here now we move to the pictorial representation. and pick some sticker pictures that my first graders would like. So there are 9 with their little tongues sticking out at you, and we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 5 that his sister gave him. 1, 2, 3, 4, 5. So when I count the 9, I would put the 9 here, and then 5 more. We would add the 5 here, and so we would get 14. Okay. Another way we could do it, we talk about making a 10. Again, I would have them circle 10 of the stickers. And again, then we have 10 plus 4 equals 14, which again is much easier for a first grader to grasp. Another thing we could do, another strategy, as Gina mentioned, we do strategies, is a number bond. The kids learn number bonds in first grade and they love number bonds. So if we take the 9 plus 5 equals 14 problem, I would circle again the smaller number, that would become our whole, and our parts always must equal the whole. So 5 is our whole, then we break it into parts. 1 and 4 make 5. And then again, here we have our 10 plus 4. And then writing this math number sentence is what the abstract representation is.
Hello, I am Mrs. Skolton and I teach 2nd grade here at the Geneva school. So here's an example of a division word problem that we might find in 2nd grade. Sarah bakes 15 muffins and gives an equal number of muffins to 5 of her friends. How many muffins does each friend get? So we would begin with our manipulatives to help the students once again have a concrete understanding of what this problem looks like. So here we're going to use our base 10 units to help us with this problem. So each unit is going to represent 1 muffin. So we're going to count them out until we get to first our 5 friends, and then we're going to pause. So here we have 1, 2, 3, 4, 5. Now as we continue counting, we're going to go back to the first one and keep grouping because we're distributing them into equal groups. So we're going to go back here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now the students can physically see that each of the 5 friends has 3 muffins in their group. So the next thing that we would do is to take a pictorial view of what this would look like. So in 2nd grade, we begin with bar models, which is the foundation of bar models that are going to build each year as they continue in the different grades here. So here's an example of what the bar model would look like for division. So here we would draw our whole, which we started with 15 muffins, and your students make much prettier bar models with rulers than I can make freehand. So we label this as our 15 muffins. Then we know that Sarah gave them equally to 5 friends. So we're going to have 5 bars that represent those 5 friends as equally as I can possibly draw them. And then our mystery is how many muffins each friend gets. Now we saw with the concrete that each friend got 3 muffins. Eventually, 2nd graders will be able to look at one of these bars and know that that one unit represents 3 muffins, but in the beginning sometimes we can draw it in to help reinforce that. So we can draw these circles to represent the muffins, 1, 2, 3 in each group here. So we can see that she gave 3 muffins to each of her 5 friends. Then when we look at it abstractly, we can actually write the division sentence out. So 15 divided by 5 groups, or broken into 5 groups, equals 3. So each friend gets 3 muffins. That's our problem.
Hi, I'm Miss Song and I teach 3rd grade. So bar model can be difficult for the kids to understand, so we try to use a lot of concrete to represent how bar model works. So I'm going to show you how it is done in 3rd grade. So to read a problem, it says Jill has 28 stickers. Peggy has 4 times as many stickers as Jill. Louis has 15 fewer stickers than Peggy. Then how many stickers does Louis have? It is a lot of information given to the kids, and they might feel overwhelmed. So what we do is we try to look at a sentence each. So let's take a look at first sentence. It says Jill has 28 stickers. So I'm going to use a highlighter and highlight Jill and 28 stickers. And I'm going to use a cube to represent Jill's sticker. So in this case, I'm going to call one unit 28 stickers. Now next sentence says, Peggy has 4 times as many as Jill. Now if Jill has 1 unit, Peggy has to have 4 units. So I have 1, 2, 3, and 4. And notice how all the units are equal. Now our next sentence says Louis has 15 fewer stickers than Peggy. Now I'm not going to use the cubes to represent Louis's stickers because his unit is not the same as Jill and Peggy. So when I draw bar models, I'm going to show you how to do Louis's. So now I'm ready to move this concrete into bar model. So let's begin with Jill. So Jill has 1 unit. So I'm going to draw a bar to represent Jill. And I'm going to call this 28 stickers. So that 1 unit, the cube became Jill's bar. And now I'm going to draw Peggy's. And as you can see in the cube, we have 1, 2, 3, 4 units. So for Peggy, we have to have 1, 2, 3, and 4 units equal as Jill's 1 unit. So now I can draw Louis's bar. So since Louis has 15 fewer stickers than Peggy, I always ask the kids, now is our bar for Louis gonna be longer or shorter? Then kids, the answer is it's shorter because he has fewer than Peggy. So let's draw that with the bar. So Louis is going to have a shorter bar. And since I'm comparing Peggy and Louis, I'm going to find the gap, the difference between Peggy's bar and Louis's bar, and call this 15 fewer stickers. Now we're ready to find Louis. Well, before finding Louis, we need to know how many stickers Peggy has. So we're gonna put 1 unit equals 28 stickers. Then how many stickers does 4 units represent? So we have to do 28 times 4. And let me quickly show you how to do the multiplication the way we teach. So we're gonna do 28 times 4. So we have 8 ones times 4. So 8 ones times 4 becomes 32 ones. Now we can regroup that 32 ones into 3 tens and 2 ones. So I'm going to write the 2 ones in the ones place, but I'm going to regroup the 3 tens into the tens place. So now I have 2 tens times 4. Let's do the same thing. 2 tens times 4 equals 8 tens. But don't forget, we have the extra 3 tens that we regrouped. So I'm going to add the 8 tens and 3 tens together to get 11 tens. And then I'm going to regroup the 11 tens into 100 and 110. So regroup the 100, and we have 110 in the tens place. And now I have 100 in the hundreds place. So now we figured out how many stickers Peggy has, 112 stickers. So I'm gonna go ahead and mark that in the bar. It is always important to label everything in your bar because sometimes kids forget what information they have found. So now we're able to figure out the Lewis's sticker, which is the ultimate question mark. So how many does Lewis have? So I'm going to put a question mark for Lewis's bar because that's what we're trying to figure out. Now since Lewis has 15 fewer than Peggy, I need to take away 15 from 112. So again, when we do subtraction or addition, we always go back to concrete when kids seem to be struggling. So I'm going to show you how to subtract using the base 10 blocks. So the problem is 112 minus 15. So let me show 112 with the base 10 block. So I'm going to put 100, 110, and 2 ones. Now here is a problem. I cannot take 5 ones away from 2 ones. So what do? We regroup 110 into 10 ones. So I'm going to go ahead and do that. 5 and 10. So how many ones do we have? 12. How many tens we have? 0. So I'm going to show that as the abstract 2. And I have 12 ones. Now I'm ready to take 5 ones away. Ta-da! And how many ones we have? 7. Now here comes another problem. I have to take 110 away, but I have no 10s to take away. What do? I regroup 100. That 100 turns into 10 tens. So 2, 4, 5, and 2, 4, 5. So let me do that in an abstract way. So I have 10 tens. So now I can take away 1 10. So how many tens we have? 9 tens. So now we figured out how many stickers Lewis has. 97. So I'm not going to forget to write that down next to my question mark. So we figured out that Lewis has 97 stickers.
I'm Mr. Shirey and I teach 4th grade. And you're going to see how all of these steps kind of culminate as they get into their later grades. And so this word problem is going to take multi-steps. So it's going to take all these different strategies they've been learning year after year, and they're going to use this for the word problem they'll get in my class. So this problem is, Claudia bought 1 filing cabinet and 2 cupboards. A filing cabinet costs 3 times as much as a cupboard. She paid $1,005 altogether. What was the cost of a cupboard? So what I'll have the students do first is similar to Miss Song. Let's underline the important information. Let's highlight it. So she bought 1 filing cabinet, 2 cupboards. Okay, a filing cabinet is 3 times as much as a cupboard. She paid $1,005 altogether. And then I'm going to underline the question, because sometimes with 4th grade students, they like to be silly or they like to look for different questions. We're not concerned with Claudia's shopping habits. We're not concerned with why she likes these things or what she puts in them. We're concerned with the cost of a cupboard. The cost of a cupboard. So I'll underline that. The cost of a cupboard. Okay, we're going to go from what we know to what we don't know. So what we do know is she paid $1,005 altogether. So dollars, 1,000. $5 altogether. And what did she spend that on? She spent it on a filing cabinet and cupboards. I'm going to put that here, but I'll caution the students. We don't yet know if these are equal portions of $1,005. We don't yet know that. So what can we use from this question to figure that out? Let's see. So she has 1 filing cabinet, 2 cupboards. We don't know if those are equal portions. Let's look at this sentence. A filing cabinet costs 3 times as much as a cupboard. That looks like that could help us. So similar to Miss Song, we'll have this represent 1 cupboard unit. So here's 1 cupboard unit. And a filing cabinet will be 3 times as many, so 3 cupboard units. So 1 times, 2 times, 3 times. So a filing cabinet is 3 cupboard units. I'll write that down. So filing cabinet equals 3 cupboard units. Now we have equal units. Okay, let's go ahead. See it on this page. Same problem. This is the same information I just did. So filing cabinet is 3 cupboard units. The total is $1,005. And that total is shared among filing cabinet and a cupboard. And we have their equal units now. So how many cupboards did she buy? She bought 2 cupboards. So 1 cupboard. 2 cupboards. And she bought a filing cabinet. And a filing cabinet is 3 cupboard units. So here's 1. Here's 2. And here's 3. 3 cupboard units. I'm going to rewrite that one just so it looks a little straighter. Three cupboard units. Now we're saying $1,005 is equally shared among 5 units. So $1,005 equally shared among 5 units. Okay, this part I want to show using the board. I want to show you using the board. So let's represent this. These are our base 10 blocks. They're magnetic. They're really fun. The kids really like these. I like them as well. So let's put our number up there. All right, so we have 1,005 divided equally into 5 groups. So 1,005 divided equally into 5 groups. And one thing that Singapore Math really encourages them is to use all of their skills. So we can actually check our work as we're doing it. And how we're going to check this is 5 groups of a certain number should equal 1,005. So 5 groups of our quotient, our numbers, should equal 1,005. So we can do this to check our work as we're going. Okay, so I'll get my 1,000, and I'll get my 5 ones. So the first step, we'll start with the highest place value, the thousands in this number. I have 1,000, 1,000. As 1,000, I cannot share 1,000 as 1,000 equally among 5 groups as 1,000. If I tried to do that, that'd be the same as saying, okay, 5 times, if I put 1 and I say I can share that, that's the same as saying 5 times 1,000 equals that answer. That doesn't work. That doesn't work. Okay, so I can't share 1,000 as 1,000 among 5 equal groups. But I can regroup 1,000 as 10 hundreds. Regroup 1,000 as 10 hundreds. So let's regroup that as 10 hundreds. Here's my 10 hundreds. And these 10 hundreds I'll equally share into 5 groups. So I'll start by getting each group 100. These are our 5 groups, so it's 3 groups so far. 4, 5. Those are 5 groups. And I can share more. Each group can get 200. I can equally share 10 hundreds into 5 equal groups, and each group gets 2 hundredths. That's why, when doing long division, they'll put 2 hundredths right here. And so far, out of our number, we've used 10 hundredths or 1,000. 1,000 out of our number. Now let's move on to the tens. Currently, in this 10 place, there is 0. I'm not showing 0. There's 0. Now we'll move on to the ones. 5 ones. I have 5 ones left. 5 ones left. And let's share 5 ones equally among 5 groups. Let's group them 1. And each group gets 1, 1. And this can just be a really powerful visual reminder because sometimes students don't know which place value to do unless they know that this is thousands, hundreds, tens, ones. So each group just got 1, 1. All right. And that's what I'll show students the first few weeks just to help them get a really good connection with what they're doing in division. That's the same thing you saw with Mrs. Skolton, what she did by splitting into equal groups. Just so we can see our problem, I'll take all of it off. All right. And now we'll do the abstract. So 1,005 ones equally divided into 5 groups. Well, 1,000, just as 1,000, we cannot equally share it into 5 groups, but as 10 hundreds, it equally shares twice. 0 tenths. 5 ones are left from our number yet to be divided. 5 ones divides equally into 5 groups, 1 time each. Make sure you guys can see it. And we divide the 5 remaining. So 1,005 divided into 5 equal groups is 201. Let's look at our question again. What was the cost of a cupboard? Not all the cupboards, not all the filing cabinets, but a cupboard. A cupboard costs 201, and this part's important, dollars. Making sure we have our units. So $201 is the cost of 1 cupboard. So what was the cost of a cupboard? Not what was her shopping habits, not what is she going to put in those, but each cupboard costs $201.
Hello, I'm Mr. Octef and I teach math here, and I'm going to be going over a 5th grade problem. Okay, so here's the problem that I'll be going over. It says the ratio of cows to pigs is 7:3. If there are 32 more cows than pigs, how many pigs are there? So first of all, the students are going to be encouraged and sometimes required to draw a bar model. And so they're going to look at this ratio and they're going to first be able to understand the ratio. So they would know that the 7 represents the cows and the 3 represents the pigs. So from this ratio up here, they're going to be asked to draw a bar model to visualize that better. So when they're drawing their bar model, they're going to draw a cow bar, and that's going to include 7 units. And then they're going to have another bar for the pigs, which is going to be represented by 3 units. Okay? So then it says we got to piece the rest of the information into the problem. So it says if there are 32 more cows than pigs, how many pigs are there? So that second piece of information, they'll go ahead and they'll label on their bar model. So you can see that the bar model represents the problem above. The next step they would notice is that 4 units equals 32. So that's what they would write on their paper. They would say, okay, I can see from my bar model that 4 units equals 32. Then their next thing, and they will know is, okay, I need to find out what 1 unit is because I'm almost getting to my answer. If I can figure out what 1 unit is, then I can figure out how many pigs are there because there's 3 of those units. So the next step they would determine is that 1 unit equals 8. And in 5th grade, I wouldn't require them to do the division because they would be able to know that if I divide 32 by 4, I will get 1 unit equals 8. So then to figure out the pigs, they would say, okay, well, what does 3 units equal? Because 3 units is basically the answer to my problem, and 3 units equals 24. So from this bar model, they'll be able to see that there are 24 pigs. So this is the power of using bar models like this to represent problems. It gives them like some tools underneath them to attack problems. and to visually see what's going on in the problem. Okay, so they will definitely need that as they get into 6th grade. You'll see the next problem, how it jumps up a notch, and so they're going to have to really be able to draw bar models and piece information on the bar model to represent what's being asked of them. So the next problem is a 6th grade problem, and I'll go ahead and read it, and then I'll let you guys have at it for maybe for 3 or 4 minutes. Okay, so here's the problem. 88 children were in a swimming camp. 1/3 of the boys and 3/7 of the girls wore goggles. If 34 students wore goggles, how many girls wore goggles? Okay, so this, when I first started looking at problems like this, I thought, well, I can use a system of equations to solve this, and I wasn't sure how a 5th grader or how a 6th grader could do it. Okay, so I would encourage you guys to try to use what you observed throughout tonight to try to draw a bar model to represent the information that's given to you. Whatever you guys can gather from the word problem, to put it into a bar model to make sense of it. So I'll give you guys about 3 minutes. Okay, time's up. Any answers? I'm just playing. There's a lot going on in this problem. And I did want to say something that I've actually seen a student's paper come back with algebra on it to solve it. And clearly it wasn't done by that student. I knew it was a parent, and I thought it was awesome. So, anyways, I'm going to show you how this can be represented using bar models and how clever the curriculum encourages the students to think. Okay? So I broke it down into 3 parts. I wrote a lot down, so it's mostly to just make sure that there's a clear understanding. So I'm going to go ahead and I'm going to try to explain this to you. So the first step is to create a model with the given information. Okay, so here's what the model would look like. So if you, 1/3 of the boys, okay, so 1/3 of the boys wore goggles. So here I have the boys labeled, and in my picture, I have 1/3 of the boys wearing goggles, okay? The other piece of information says that 3/7 of the girls wore goggles. So 3 out of the 7 wore goggles, and I even put the fractions there so that we can see that this is 3/7 and this is 1/3, okay? Also, I purposely drew the boxes different because there's clearly a big difference between boys and girls. So the boxes are different. Yeah, that was kind of a joke, but it is important. But it is important that the boxes are different because they do represent different numbers, right? So, and we know that there's a total of 88 children. Okay, I don't know how it's distributed yet. And I do know that there are 34 students with goggles. So here I have 34 students who wear goggles. I can also find out that there are 54 students without. Okay, maybe some of you guys wrote that down on your paper. It's important to just write down as much information as you can gather from the problem. So here's my bar model. It's a good way for me to attack this problem, right? So a student can look at this problem. I bet you there are students in other schools that would look at this problem and just say forget about it, right? But our students will hopefully be able to dissect the problem and then draw a representation using bar models to better understand it. So what else do we know or can gather from our model? So if I was presenting this to my students, or we were going through this, these are the questions that I would ask them, and we'd go through it. So this is the clever part, I think. So, we were told above that that together, this 1 boy unit and the 3 girl units equals 34, right? Because 34 of them wore goggles. So what I can do is I can then group these together, similar as what was done earlier in the evening, right? And say that, okay, well, 1 boy and 3 girls, this chunk right here is 34 students, right? And then this other chunk right here is 34 students. So I've used up 68 students. So I can find out the difference. Whatever that difference is, I know that that's shared between 1 boy unit and 1 girl unit. So that's where I'm going next. So these remaining 2 units have to equal 20. Because if I take 88 and subtract out 68, I'm going to get 20 left over between these 2. Okay, so now I know that 1 boy unit plus 1 girl unit equals 20. So, can we use the additional information to solve the problem? Okay, looking at this. So now I know that 1 boy unit and 1 girl unit equals 20. Okay, I'm not sure if you guys can see where I'm going, but it's almost the same strategy. I can then say, okay, well, this is 20, this is 20, this is 20. So now I have 4 units with whatever's left over. So I'm going to show you how I So here, I've showed that now I know that this is 20, 20, and 20. So here we have 60 units. Or not 60 units, 60 children. I'm gonna subtract that from the total of 88. And then I'm gonna see, so 4 girl units equals 88. Okay, so now we're going back, now we're going down into like 3rd grade, possibly even 2nd grade, right? So once we've gotten to this point, the kids are like, they're ready to go, right? They can see it, they can taste it. No, I'll explain this part right here. So here we have another simple bar model where we have 4 units. Again, these 4 units are here, right? Equals 28, which is the remainder, the 88 minus the 60. And here it's like the 5th grade problem where we have, okay, 4 units equals 28. I can divide that by 4 to get 1 unit is equal to 7. And then they know that 3 units equals 21 because they know what 1 unit is. Now, how did I get the 3 units? Because if you go back to the original bar model, you can see that we're asking for the 3 units there. How many girls wore goggles? Well, these are the ones. These are the 3 units. These are the ones that wore the goggles. So your answer is going to be 21 girls. So you can kind of see how clever it is for the students to arrive at an answer. Where before coming to this school, I would have thought, I'll teach it to an algebra, because this can be solved using substitution, systems of equations. Maybe you guys can remember doing that in college or high school even. So I hope you guys can, I even did it just to see. So this is what it might look like. You would define variables, let B equal the number of boys, let G equal the number of girls, and you say, okay, boys plus girls equals 88. 1/3 of the boys plus 3/7 of the girls equals 34. I'm not going to go too much into the details on this, but that way you guys can see that these problems actually can be solved with what they're learning in the Singapore math, and it does give them a great way to attack otherwise complicated problems.
Do you guys have any questions or comments or anything you want to ask while we're here? Yes.
So one thing I had a problem with, I love math, by the way,
Yes.
and I spent a lot of time with math in my schooling. But when it came to and I spoke with Mr. Ostef about front-end estimation.
Right.
So I feel like the curriculum spends way too much time on estimation. I love what you showed tonight. I think 100% going for that. But when it comes to spending more time on estimation than on actual solving problems, I find it's a waste and it's confusing.
Well, I mean, Kevin can probably speak more specifically, but I think like front-end estimation only comes up, is it in one chapter of the
Yeah.
whole year? So it's not a lot. But the reason I mean, my understanding is the reason why there is always estimation in all of these grade levels is because it's how kids check their work. It's how they go back and they say, was this a reasonable answer? Which I can tell you, kids are not good at doing. It is that how many groups of 5 are in 1005 and they write 5,000, what is that, 20?
Yeah, so they know,
25.
using estimation, they know it's not going to be.
Yeah, so just using estimation, they don't have to do that math in their head. They can easily look at it and say, no, this is not reasonable. I need to rethink this. And that is a huge part of math. And I think the more difficult math is for students, the more important it is that they have that skill.
Right, I understand the rounding and all that.
Yeah.
I had a problem with the systematic means. Like first we're going to round this, then we're going to round that, and then we're going to round this
Right.
thing, and da 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 da. And before you know it, it was like 10 steps to get it to an estimation.
Right.
And I understand it's only one thing, and I hope I don't see it again.
Yeah.
But I'm bringing it to light because I did feel like this is steering my kids down the wrong path, where you're spending all this time doing an estimation and you can't just solve the problem.
Right, but the problem with that kind of thinking is that if we just teach kids just solve the problem, they have no skill to say, is this logical? And so that's where, unless they're going to solve the problem multiple times and make sure they keep getting the same answer. So again, that estimation is teaching them to think, is this reasonable?
So I have 3 kids that have gone or are going through this. And I can tell you one of them is really not good at checking their work. Like really not good. But the estimation thing is helpful because intuitively, is this the right answer? Could this be in the realm of possibility? And if you're thinking about estimating, that can be a really helpful tool, especially if you have a child that just wants to hurry and plow through stuff without then thinking about how they arrived at those answers.
Right, and I also want to add, this is kind of partly why I go through SWR, because it is the same thing. When you look at SWR, you think, I do not want my kid doing this when they write. But being able to think through numbers flexibly and in different ways is a huge part of teaching that flexibility in thinking. So it's not something that they're hitting all year long, but it is something that they do hit upon each year. Because it is teaching them that flexibility in thinking.
And it I noticed it helps them with the mental math too.
Yes.
Because that chapter comes right after estimation, so they use their rounding as a strategy to do mental math quickly. So
Right.
if they understand that 46 rounds to 50, then they can just use 50 to do mental math.
Right.
Right, again, rounding is all good, that's one thing, but
Right.
the systematic method of the front-end estimation was just
Yeah,
a
it's
bear.
It's very different. But again, I just want to say, like, that's where I always go back to. This system has been proven over and over and over again, and the way that we have been educated mathematically in the United States has been proven not to work over and over and over again. So I always, when I look at something and okay, this is different, I'm not quite sure why they're doing it this way, you almost want to come to it from the premise of, there probably is a good reason and I need to find that, rather than this is different and I don't like it. It is just a different, it's coming to it with a different mentality.
Okay, and I had another
Yeah.
question. How did you guys choose which kind of Singapore? Because they offer multiple versions.
Yes. So the reason why I like Math in Focus is a few things. One is the support materials that they have for teachers that make it accessible to all different kinds of learners. So they have support materials for our learners who are very accelerated. They have support materials for the learners who need to be taught a lesson multiple times. The other thing that I like about it is it has the philosophy that the math knowledge is to be given at school. And so when things are sent home, like as in a reteach, they have a portion on that paper that shows you how your child's been taught how to do that problem, so that it's not, because it is a very different math pedagogy, so it's a little easier on the parents. And then thirdly, Math in Focus has taken Singapore math, and they introduce the topics in the same grades that kids are being tested through standardized tests. And because we are a school that does standardized tests, it's really hard when your kids are doing a curriculum that they're just not being taught certain concepts and then they're getting tested on them. So it could look like you're not teaching them well or they're not doing well in math, when in actuality they just haven't covered those concepts yet. Wait, yeah, go ahead, Julie.
Mine's real simple because
Okay.
we haven't started long division yet, but we never pull down arrows anymore.
The biggest reasoning behind that is that tends to lead kids to put their quotient in the wrong place value.
Okay.
Yeah, so, and also then at that point, the numbers are just abstract. It's just a 5, it's just a 2, it's just a, and you'll end up hearing, okay, 5 goes into 5, how many times? But we want to develop the sense of this is a 5 hundredth, or this is 5 tens.
So
that's
never you, I never, because she's gonna look at me like, I don't know what.
You'll have to ask beyond my grade level if they never do that again. But we try to do the whole place value, that's what we're trying to do.
Yeah, I let them use both strategies. Because I found that sometimes when you're bringing the arrow down, I still want the students to be able to say, okay, 5,000s into, so still accounting for the place value, because Mr. Shire is right, and we've talked about this, the quotient is the hardest part because they may skip a place value, right? And so the answer is 403, but so many of the students will put 43 unless they're actually paying attention to place value. So I'm okay with either of the strategies because I've seen it done both ways. But the difference between the arrow that we're teaching now is like in your head, you're breaking up based on place value. It's not just a number. It actually represents a value, right? Beyond just the number, right? So they've been learning about place value ever since, kindergarten or first grade. And so that's something that they have that we didn't have going into long division. And so the steps are there for them to make and to be able to do the long division successfully.
Yeah, it kind of like lends into that then, because now they know what they're doing, and then they go to maybe if they have a high school teacher who does it, they can kind of go to the concrete to the abstract that way.
And that's I hope that came through. That was the last thing I wanted to say, is that we really start out where we're going. Concrete, pictorial, abstract, and then as they go up in grades, a lot of times they're fluidly going back and forth between the different types of understanding. When they need the concrete, they can go back to it. But just like with Kevin, when he did his problem, and it was, they have like 4 units equals 28. They easily just can know that's 7. We're not going to make them write out that whole problem. And that's the nice thing about Singapore math, is it does give them such accurate,
Confidence.
Yeah, well, confidence, but yeah, mental math skills. So they're not having to do so much. Yeah, but I think what he's saying is you have to give them that foundational understanding first, and then they can use, different strategies because they have the foundational understanding and they know what they're doing. Yeah. Yes.
Yep. Thank you for explaining the bar models. I don't know if I'm the only one, but
No,
that's,
you're not.
that's an amazing strategy, though, and it makes sense now that I see it up there. But how do you stop just shy of? How do students transition from this, approach where they're very bound to and understanding the physical reality of it, and into the abstract? So, graduating from the bar models, if you will, into the realm of algebra, pre-calculus, and so forth. How do you find that students make that transition?
very easily.
Hmm.
So yeah, I mean, just in our family, we have 4 boys, and 2 of them are very mathematical. And so my youngest one, I've gotten to see go into high school, and he's in pre-calc right now. And it's been a very easy transition, and that's partly why we transition them in 7th and 8th grade to either pre-algebra and algebra, or algebra and geometry, depending on where they are. So they actually make that transition here with Mr. Otto.
And some of my students in algebra, they'll be like, oh, this reminds me of a bar model. This reminds me of stuff that I've done. So they're already making connections, and they're able to see it better than most students because they do have that deeper understanding, right? And so that does come up in algebra, and I think it does definitely help them do better in algebra, into geometry, and they do become better problem solvers.
I look at it as like a toolbox. Like
It is.
I was taught with a hammer. If it needs a hammer, you got a hammer. But like I feel like my daughter's got a few more tools in her toolbox when she hits a math problem than I do. And I think and we're like touring other high schools and things to look at, and it's kind of interesting to see her be drawn to sciences, math, and those kind of things. I think largely because she has more than a hammer.
And I would say our kids we start our standardized testing in 2nd grade, and our math scores are some of our highest scores across the school, and they aren't using any bar models on standardized tests. It's all traditional algorithms. So it's not even that once they get to algebra they can transition. It's just they're understanding in class that, again, those bar models are a tool for them to solve a problem. So they can solve a problem without them as well, and that's where that flexibility comes from. But when they get stuck, they have something to fall back on. And you could see, trying to figure out that last problem with just a hammer was really hard. Yeah. Any other questions? Okay. Well, I'm really glad you guys came. I hope it was helpful in understanding why we're excited about this math program. And we've been using it since 2012, the fall of 2012. A long time ago, but when Leanne started, that was her first year. I gave her all new curriculums. And yeah, it's really, my son, I'll brag on him. He is one of 3 freshmen that tested into Algebra 2 honors in his public high school. So there's a lot of them, a lot of freshmen. He had the highest grade in the class. He got 120% in Algebra 2 honors. And it is just, even my oldest son he's an engineering student at UCI, and I was showing him this problem and asked him if he could try and solve it without algebra, and he couldn't, and I showed it to him. He's like, it's so beautiful. It really is. It's such a beautiful thing, and even just that a 6th grader can solve a problem like this. Yeah.
I do have one more question too. So one of the things, the Department of Education last year came out with additional reporting showing Common Core gets ragged on all the time,
Yes.
right? And even now the DOE is ragging on Common Core that it's
Yeah.
not achieving the objectives it was set out to do, right? So that's why when you see
Yeah.
Common Core approved,
Yes.
you see red flashing lights.
And I would tell you, it's much like I would say just traditional education is not producing the results. And
Right.
so I would say most of that problem that I showed you that said new math, if you look at it, it actually is just a good mental math strategy. They're trying to count from they're counting up from 12 to 32, and they're trying to get to a 5 because it's much easier for us to deal with 5 and zeros, right? That is a crazy way to teach someone to solve with paper and pencil 32 minus 12. And I think it's so much, it's like the whole word approach to language. You don't teach children how to read because they're missing so much of the benefit of learning how to read analytically. And so I think that we have, whether it's politicians or just educators who are so far removed from brain development and child development, that they just don't understand education, and then they're creating curricula. So I'm not sure, I mean, when you look through the Common Core goals, there's not really any bad Common Core math goals. Like, I think if we looked at English and some of the language arts, we would all be, and even some of the Common Core curriculums, they're getting a huge political, philosophical bent into the word problems. Even if that was a great math program, we wouldn't want to use it because you're teaching kids things when you're talking about, you know, I'm not going to say it because we're filming, but you can teach kids things by what the word problem is about. I think that's, and I also think that trying to implement a system like this or a program like this without training for teachers, Li Ping Ma wrote a book called, is it the Understanding Elementary Math, and she's from China, and she comes out here, and I think she was doing her doctorate, and she was studying American math teachers versus Chinese. I would say if you want to understand why Common Core fails, read that book, because Common Core is failing because our teachers are not being equipped to teach well, and it's not just math, it's pretty much every subject, and that's why they fail, and that's why the last, you know, decade after decade after decade of the new educational philosophy fails because we're not trying to solve the problem the right way.
Yes.
And go back to classical education, train your teachers well. So that, I mean, that's my take on it. Yeah. Any other?